This tutorial will discuss the steel connection design available in ETABS. ETABS offers three types of connection design: beam to beam, beam to column, and column footing or base plates. If we zoom in on the 3D view, we can see a typical beam to beam arrangement. Note that the floor joist is not as deep as the girder. For this model, we have a W10 section framing into a W18 section. If we go to the steel connection design preferences, and select the Beam to Beam tab, the program provides three types of connections: vertical plate full, vertical plate partial, and horizontal plate. The type of connection used is determined by the plate depth schedule. Clicking this button, we see the rules used by the program to select the appropriate connection. We will leave the default mode set to auto. This means that the program will use the schedule shown below. We will not alter the defaults, so the program will use the horizontal plate connection because our beam is 10 inches in depth. If the beam was larger than a W10, but less than or equal to a W30, then the partial plate would be used. Larger than a W30 would use the full plate connection. On the Preferences form, we can set the bolt types, the bolt sizes, the hole types, the weld material, weld thickness as a multiple of 1/16 of an inch, plate material, and plate thickness. Various offsets and detailing dimensions are also shown. After reviewing this information, click OK to close the form. Next, we will review beam to column connections. Here, the program can design four types of connections: shear major axis, shear minor axis, moment major axis, and moment minor axis. All of the beam to column connections in this model will be moment connections. Again, the user has control over the bolt, weld, and plate settings. The last type of steel connection design that ETABS can perform is for column footings. Here, plate thickness and dimensions may be set, anchor size and length defined, the increments to use when increasing the plate width and height, and the various offset dimensions, as well as the bolt clearances. Note that the variables in blue are program determined, and those in black are user defined. After we have reviewed all of the preferences, we can click the OK button to close the form. The last thing we will review before running the design are the design combinations for the connections. In this model, we have only two load patterns, dead and live, and as a result, we have only two design combinations, 1.4 dead and 1.2 dead plus 1.6 live. Now we are ready to run the steel connection design. If we zoom in on the plan view, we can see that the governing demand capacity ratios are displayed. A right click on a beam-to-beam connection brings up the connection form, which shows the same governing demand capacity ratio and lists the governing design checks for each combination. A click on the Details button shows all of the design checks performed and lists the demand capacity ratio for each one. Note that all passed and that the governing ratio is indeed 0.536. All of the supporting calculations are provided. This design document may be printed or sent to Word. Returning to the plan view, if we look at a beam to column connection, the max DC ratio for both combinations is acceptable. And the Details button again shows all of the checks that were performed. Right-clicking on a beam-to-column connection that has a DC ratio greater than 1 shows that this connection failed due to weld strength at the tension flange. A check of the details shows that this is the only check that failed. And we can review the calculations if needed. To rectify this design weakness, we will click on the Overwrites button and increase the size of the weld thickness. We will go from 4/16 to 6/16. Once we click the OKs, the design is rerun and we see that the governing DC ratio has dropped to 0.7. A right click and then the Summary button shows that this connection is now acceptable. Lastly, we will take a look at the column base design. A right click at the column base shows that the governing DC ratio is acceptable. And a click on the Details button shows that the design passed the 3 checks performed. Supporting calculations are provided for each of the 3 checks. This concludes this tutorial on steel connection design.